Hi, my name is Zane Nabulsi. I'm the CEO of Drone Labs. Thank you for joining us. Today we're going to show you our drone detector product in action. So sit back, relax, and enjoy the show.
Hi, I'm Phil Wheat, CTO of Drone Labs, and we're going to go through the hardware in our fixed unit, which is our longest range detection unit we offer. The first thing you'll notice is our industrial case. We use this, it's spray rated, all weather rated, so it's able to handle anything that you throw at it. We have it actually set up with 2 vents, again spray rated, to be able to do passive cooling. It makes it nice and simple, no moving parts, so that you have long life and real durability in these. On the top you'll see our long range omnidirectional antenna. We use this for listening in on drones that we can actually detect the telemetry. When you see us showing some of the GPS work, it's because we're able to listen in on that with this omnidirectional antenna, pull those in on known protocols that we have. On units that actually have other control systems that may not be sending anything but the control itself for the units, we actually have our antenna right here. We actually use this to be able to connect in on the quadrants to let you know which direction the drones may be at. We actually have 4 of those around that are able to pull that in with our parabolic reflectors to give us both directional and additional range. Those go through our custom antenna multiplexer into our software-defined radio. We use software-defined radio to enable us to look at any frequency between 10 and 60 gigahertz, 10 megahertz and 60 gigahertz. So as new transmitters come on the market, new protocols happen, it's all just a simple software upgrade, and we're able to keep these systems moving forward as the market changes. All that comes down into our industrial computer, i5, 8 gigs of RAM, has plenty of horsepower to be able to do signals processing, to be able to do communications with your back-end systems. On the other side, you'll actually see we have an Ethernet connector that ties into your systems. We're able to do a TCP/IP data stream that pushes back in, that gives you information on the entire system, what's going on, status, and that's the ability to integrate into your back-end systems and run this system completely headless without any other connectivity. If you do need a little bit lower tech integration with your systems, say a siren or a strobe light to let people know what's going on in the area. We have 2 relays here that can be configured to activate upon different events, so that you can actually do a quick integration there, custom plug, couple of wires, and you're able to tie into your systems without any programming at all. We've got our power supply set up to either run through a power plug or to be hardwired into your power systems. It's a universal power supply, 50 or 60 megahertz, and 110 to 240 volts. So we're able to take on pretty much any power that you have. And then on the front of the system itself, we have our all-weather microphone that does audio detection, so that if you do have something that's running even completely RF silent, we have that in there to be able to give you a backup capability to know exactly what's going on in the area at all times. So basically the system comes in, latches up, and ready to be mounted. The system is built with brackets to mount on a non-metallic pole to give 360-degree detection, or you can actually mount it on a wall through the mount holes and be able to use that on a 270-degree detection depending upon how it's placed in your system. So let's look at what just a test detection is going to look like. You'll see that here we've got the laptop with our diagnostic screen set up. It's monitoring what's going on the detector itself. And then I have here a 3DR Solo and its controller. So what we're going to do is just turn it on right here, a nice easy detection, and show you what happens when you get a detection. So I'll turn on the controller and the drone itself, and these will take just a second to boot up. You'll see here that it does take a moment for the drone itself to get its computer booted up and everything going and ready. So it'll just take a moment, and what happens with this is a known drone type. So when we do our detection, we're going to pop up to top level of confidence. So it's going to take, it takes just a moment again to boot up. It's booted up, it's working with the handshake on the drone itself.
Detected. 3DR Solo.
Before the controller even does the handshake, we actually have the detection of the drone itself. We know what it is, we know what type it is, so you heard it say that, and now we got a full detection there. So what we're going to do now is turn it off, and what we do is, one moment, we actually have a confidence decay that occurs. What happens with that is we actually have the system, we want to make sure that it's left the area, that it's not a temporary loss of signal, so that we don't raise alerts multiple times on the single sighting. and you'll actually see that this will shut down, and then the confidence will decay on the detector, and you will be noted when the drone has left the area. And it will take just a couple of seconds for that to occur. The drone is completely off now, confidence is decaying, and we will, normally takes about 15-20 seconds for that to happen.
Alert. Drone sighting ended. 3DR solo.
And there you have the notification of that the drone has left the area and which drone it was that the detection was lost on. So a nice, simple scenario, but you can see how the drone detection works with our system.
Now that you've seen an up-close detection and we've shown the drone detector works, now we're going to show you the detector working at distance. You can see behind me, Phil's about 300 meters away. We're going to go ahead and do a detection real quick. I'm on the phone with him. Phil, go ahead and turn on the drone. What's going to happen is Phil's going to turn on the drone. It'll take a second for the drone and the controller to communicate, and then once they start communicating, we'll detect them. Let's wait for a minute. Let's hear the detection.
Drone detected. 3DR solo.
Okay, we got a detection. So here we are at distance. You can see that we're easily able to detect that drone without any problems whatsoever. I'm going to have Phil turn off the drone. We're going to lose the detection, and then we'll do another demo by losing line of sight. Phil, go ahead and turn off the drone and start heading behind the tree. So Phil's turned off the drone now. We're going to lose the detection, and now you can see he's gone behind a tree. We've lost line of sight. Now, this is a problem for most every other type of detection, right? Depending on the detection methodology, video, thermal, radar especially.
Alert.
You can see we just lost the detection there, but with video, thermal, and radar, unless you have line of sight, you're not going to detect. With our technology, we don't need line of sight. I'm going to have Phil turn on the drone now. Phil, go ahead and turn on the drone. We're not going to know when he does it, but we'll get a detection.
Drone detected. 3DR solo.
Okay, we just got a detection. So you can see that even though we don't have line of sight, we got a detection on the drone. We don't require line of sight. That's the beauty of our system. What we're going to do now is we're going to show you the drone flying below a tree line. One of the biggest problems with video detection is that it cannot detect a drone unless it has something to discern it against, like the sky. So I'm going to go ahead and have Phil do that. Phil, go ahead and fly below the tree line. Phil's going to start up the drone and fly below the tree line, and notice how hard it is to see. This is a major problem. Most of your video detectors today, unfortunately, are not able to discern the drone against any other backdrop except the sky. Okay, folks, now I want to show you one of the biggest problems with video detection. With video detection, they can easily see a drone in the sky. Now, it's not that easy, but at least it can see it. But watch what happens when Phil dips it below the tree line. You'll notice it's slowly starting to disappear, and then it pretty much disappears at that point. This is a major problem with video detection. Video detection is not able to discern the drone from the background. Here at Drone Labs, one of our favorite things to do is to deal with misconceptions. One of the most popular misconceptions that we've come across is that we can't detect autonomously flying drones. Nothing could be further from the truth, and we're going to prove it right now. What I'm going to do is I have the drone ready to be turned on. I'm going to go ahead and turn on. The drone behind me is already on. I'm going to turn on the controller, and we're going to get a detection. After we get the detection, then what will happen is I'm going to set the controller down, and we've set the drone up to fly autonomously. We will fly the drone. You will note that we never lose the detection. One of the beautiful things about our product is not only do we detect it, but we would detect it before you can even fly it. So right now, we're waiting for the two to communicate. Once they communicate, we'll detect it even before the drone has a chance to get all the GPS coordinates so we can even fly it. Once that happens, we'll fly it autonomously, and then you'll see exactly what I'm talking about. We can absolutely detect autonomously flying drones.
Drone detected.
Okay, so now we have the detection. So now I'm going to take the controller. I'm going to set it down. And now I'm going to give Phil the signal to go ahead and have it fly autonomously. And away it goes. Well, as you can see, we never lost the detection on the drone. And we can easily detect these autonomous drones. In fact, we detect them before they even get off the ground. So before they even have a chance to fly them autonomously, we're detecting the drone. So I'm going to give Phil the signal, and then I'm going to turn off the controller in mid-flight to show you what happens when the controller's not turned on a drone that's flying autonomously. Here we go. I'm giving Phil the signal. The drone's taking off. And now I'm going to turn off the controller. The controller is now turned off. Watch what happens. The drone freaks out and returns home. You cannot fly an off-the-shelf drone without the controller turned on. And there you have it. Don't take my word for it or anybody else's. Try it for yourself with your drone. You'll see what I'm saying is true. Don't believe people who are telling you that we can't detect an autonomous drone. We absolutely can.